Hello everyone. In this video, we are going to see a analysis about a fixed bias and voltage divider bias. I am Mahalakshmi from B11 batch and my batch members are Mukesh, Santosh Kumar and Silamarasi. Let's first see the experiment of fixed bias using Multisim. It is to analyze the fixed bias. That is, here analyze means to find Q point. That is, the Q point is IC and VCE. Let's first see the concept of this experiment. This is a circuit, presence of RB, RC, and IB, IC, the flow of currents. The reason behind it, that is the reason behind the fixed bias circuit name is for the given supply of VCC, when we fix RB, the IB will be fixed. This is the reason behind the name fixed bias. We are going to find IC and VCE. Let's see the formulas of them. Let's take input circuit, that is base emitter circuit. When we apply KVL, we will get VCC minus IBRB minus VBE. When these are exchanged to IB equal to, we will get VCC minus VBE by RB. Then when we take collector emitter circuit, here we are applying KVL, the same VCC minus ICRC minus VCE equal to 0. Since we need VCE is equal to VCC minus ICRC. And we know the formula that IC is equal to beta IB. Let's now simulate this in Multisim. We can get the components from the left corner. Let's first take source, the first thing in left corner. We need VCC. Then ground. Search for it. Next one, we need resistors. So after the source, we will have a place basic. In that, we can get resistors. Here we can have the name resistors. We need 2 resistors. Then we need transistor. So on the same side, the fourth place, we have place transistors. We need BC 107 BP transistor. Search for it. We will get it. Let's close it. That's it. Now we can change the value of it. We need VCC equal to 10. So double click on it. We can change by that. On double clicking on the components, we can change the value of them. For changing the beta value of this transistor, double click on it. We will get like this. Go for edit model. Here the ideal maximum forward beta is the beta of that particular transistor. We can change this. I'm taking it as 50. Change components. Let's connect this circuit. After connecting, the circuit look like this. Now we need to find the current flowing on this and the voltage drop between this thing. So we need to find I of C, and the voltage drop between this means we will have V of 1 minus V of 0. We know that V of 0 is equal to 0. So finding V of 1 is equal is enough to find VCE. Let's find it. Go for stimulate, analysis and stimulation. Here we are going to see the DC operating point. So click on it, and in output you will have I of Q1, I of C, add it, and we, as I said, finding of V1 is enough to find VCE. So click on V1, adding it, run. We getting the output of V1 is equal to 1.5 and V I of Q1 of IC is equal to 2.07 M, that is milliampere. Now let's add another thing in it, that is a Bjt analyzer or a IC analyzer. I am using Bjt analyzer. We can get this Bjt analyzer in the right corner. Here itself they will have CEB, that is collector, emitter and base. Connecting it to them, and we can change it to interactive stimulation and running it. Clicking on this component, we will get the graph like this. It is a load line graph, that is IC versus VCE graph. And here this line is IB. That's it. Let's compare this with the calculation we are going to do. And this is a calculation I have done, finding IB. With that, we are finding VB IC, which is IC equal to beta IB, and we are finding VCE. So when we are stimulating in some multisim, we are getting IC equal to 2.06, and in calculation we are getting 2.1 milliampere. As well in VC is equal to 6.9. In calculation we are getting VC is equal to 7.48 V. Let's move on to the voltage divided bias. Here also we are going to analyze, that is to find the Q point, that is to find VIC VCE. Let's move on to the concept. This is a circuit of voltage divided bias. The name of voltage divider bias comes because they are a formation of voltage divider by R1 and R2. The voltage drop across the R1 formed forward bias to the base emitter junction. This causes IB. Hence, IC flows in the zero signal condition. Here we are going to find IC, which is that IC is equal to beta IB. Applying KVL to base emitter circuit, we will get IB equal to VB minus VBE divided by RB plus 1 plus beta RE. Here we can find voltage. We can find RB by voltage divider theorem. As we said, R1 and R2 is forming a voltage divider. So VB is equal to R2 by R1 plus R2 of VCC, that is into VCC. Then we need RB. RB is R1 and R2 parallel combination. That is RB is equal to R1 R2 divided by R1 plus R2. And to find VCE, we can apply KVL to collector emitter circuit. Here we need IE. Here the formula of IE is equal to beta plus 1 or into VIB. Let's stimulate this in Multisim. As I said, we can get components from the left corner. After connecting all the components, we will have the circuit like this. Let's change the beta value. Here the beta value is 400. Let's change it to 50. Now, as I said, we need the current flowing here, that is IC, and we need the voltage between this, that is V1 minus V3. Let's get that value. Going to stimulate, analysis and stimulation. DC operating point. We need QIC, adding it. We need V1 minus V3. So we can add expression in that. V of 1 minus V of 3. So running it, we are getting the value like this. Is VC equal to 4.5 and IC equal to 1.97 milliampere. Now let's see the calculation. The calculation is here. We are getting IB equal to 39.4 microampere and IC equal to 1.9 milliampere and VC equal to 4.56 voltage. Comparing it, in Multisim we are getting IC equal to 1.9, and in calculation we are getting IC equal to 1.9 milliampere, as well IC is equal to 4.5 and IC is equal to 4.5 voltage. This is an experiment of analysis of BJT with fixed bias and voltage divider bias using Multisim. Thank you.